This is our flipped lesson for properties of a pure substance. This will be the next entry in your vocab notebook, so everything on the whiteboards behind me will go into your spiral notebook. After we go through this lesson, we are going to do some virtual things online, but then use a lot of application with some lab work over the next couple of weeks. So the title of this one is Properties of Pure Substances, all right, and they can be broken up into two different sections. Some of the properties, the amount of matter does not matter. So the amount of matter that something has does not change some of these characteristics. An example, and I've listed three here, boiling point is one, the melting or freezing point is another, and then the density. All right, so water, I could have a 5-gallon bucket of water or a little cup of water. The boiling point is still the same for the bucket or the cup because it's still full of water. So the boiling point would remain the same, and the same thing with the melting and freezing point. Okay? If we want to find the density of something, it's the mass of the object, so how much does it weigh, divided by the volume, and the volume is how much space it takes up. Okay? So if we look at our example here for water, regardless, if I have this big bucket full or just a little bit of water, the boiling point for both containers is the same. The melting and freezing point for both containers is the same. The density for both containers is the same. The density of water is 1. So the size of the amount of the matter that is in each of these containers doesn't really matter, all right, because these three characteristics right here will remain the same because the substance water has very unique boiling points, freezing points, and density because it has a specific number of atoms, protons, neutrons, electrons. Sometimes the amount of matter does matter. All right, and here are some examples. The volume of an object. How much space does it occupy? Well, to find the volume of, let's say, a cube, you would take length times width times height. All right, so how big the cube is does make a difference in how much space or volume that particular object has. Mass. How much does it weigh? Put it on a scale, see how much it weighs. All right, and another one is solubility. How well does it dissolve? Okay, and some things that affect solubility are particle size, how big are the pieces, the temperature at which it's trying to be dissolved, and then the solute, what are you trying to dissolve, and then the solvent, what is doing the dissolving. So you might have sugar cubes, all right, in water. If we put sugar cubes in hot water, they will dissolve differently than we put them in room temperature water or cold water. All right, we're going to do some lab work with that. So these three characteristics right here, the amount of matter does make a difference. All right, how much of something there is does make a difference. So here's what we mean by these two sets. Matter does matter or matter does not matter. Let's compare two pieces of gold. So we have a piece of gold here, piece of gold here. Simply by looking at them, you can see that they are different sizes. This first one has a mass of 20 grams. A mass or a volume of 10 centimeters cubed. Okay, that's the unit of measure for volume. Okay, if we were to calculate the density, we take the mass divided by the volume, we get 2 grams per centimeter cubed. That is the density of gold. Okay, 10 gram cube over here, it has a volume of 5 centimeters. It takes up less space. All right, if we take 10 divided by 5, we still get the same answer because gold has a specific density. Just like water has a density of 1, gold has its own specific density. So these two pieces of gold would have the same boiling point, same melting point, same freezing point. They would have the same density also because all gold has the same density, regardless of how big the piece is. And this is a point that we need to make sure we drive home. All right, these are some overlying concepts that you'll see on that first quarter benchmark. Being able to understand what factors does matter play a role in, what factors does matter not play a role in. In this case right here, when we're looking at these two things, mass and volume, matter does matter because these numbers are different, but with densities, boiling point, melting point, and freezing point, the matter doesn't matter because the substance has its own specific melting point, boiling point, freezing point, and density.